Hey, good morning, everybody. Good to see you all here and on the live stream. Good morning around the world, if you're joining in. Welcome. My name is Paul Backos. I'm a developer advocate working on making the web faster and user-friendly, and currently with my focus on accelerated mobile pages, AMP. And I'm here to tell you about a combination made in heaven, as I would call it. And what I'm talking about is the combination of AMP and progressive web apps. Now, AMP makes the first hop blazing fast. If you've experienced it before, you know that is usually the case. But then progressive web apps enable amazing reliability and engagement that you will only see from a native world. But that's just on the surface. So on the surface, that combination kind of makes sense. But then we have to start from the beginning, because once upon a time, the story starts with a modern-day web developer in 2017 with a growing imposter syndrome and the feeling of drowning. And so in 1999, if you created a web page, what you did is you created some HTML markup, you added some CSS, and then you hit the publish button. You had some really cheap server. There was no /dot or anything to have the /dot effect. So really it was fairly good, and I felt like I could do anything. I felt like, oh yeah, this is amazing. I'm connected to so many people around the world. And it's a free entry for everyone. But now let's look at 2017. So you create markup, you add some CSS. Then someone tells you to definitely choose a build tool and make sure you choose the right one. You add Babel Webpack, and obviously React, because I heard millennials like React. And then so many other things that you have to do to actually be competitive in today's landscape. And then, so yes, being a modern web developer is hard. But in fact, if you're looking at it from a company angle, what does your company, let's say you're a publisher, what is your company trying to accomplish and what do they need to do? Now you go one level up and you see it gets even worse because you have a number of different deploy targets, the mobile web, the desktop web, native Android, native iOS, instant articles, Apple News, and so on. So there's a number of growing ecosystems that you need to support. And now I'm here to tell you to add 2 more to the roster. And you're like, oh no! So yes, I get it, but hear me out. So let's take a zoom-out world view, a bird's-eye view, onto what we're actually trying to do. Now, if we look at an e-commerce case, what we're actually trying to do, regardless of technology, I'll take a guess. You want to sell stuff. You want to sell lots of stuff. To sell stuff, you need to bring your product landing pages to lots and lots of places where they're seen by millions of people. And landing on your browse and product pages should be effortless and instant. And finally, the payment process should be effortless and simple as well. The user should automatically be inclined to come back and buy more over time through re-engagement. And that's the kind of experience I want. I want to start fast and then stay fast. So why does AMP solve part of this problem? Well, I'm just going to recap briefly why AMP matters here. So think about your apartment key. Would you give your apartment key to all of these people? Well, there's usually 1 or 2 that say, yeah, sure, it could turn into an epic house party. However, that's really optimistic. I think this scenario is way more likely. However, on the web, there's an ongoing challenge of having a lot of monetization and user acquisition methods in play versus the user experience. And this happened because we're giving the keys to everyone. We're giving the keys to everyone, for everyone, to our web pages. So as soon as we add a script from a third party to a web page, all bets are off, right? If you can't trust that source, they could do whatever they want on your web page. It is really like giving a key to a stranger. And so what we get because of that are slow-loading pages, non-responsive content that's shifting around, that is really, really not really great to experience. And we just had that, so I'm going to skip this. Now, the current situation is pretty bad. We have over 200 server requests per mobile web page on average. And 19 seconds is the average mobile load page time over 3G. Now, out of those 19 seconds, 77% of all mobile sites take longer than 10 seconds to load. But don't worry, it gets worse. In fact, if you look at that 10-second number in particular, it's really important, because at 100 milliseconds, an interaction, for instance, clicking on a button feels instant. 1 second, it still feels natural. You still have your context model. But then at 10 seconds, you lost the user's attention. And yes, that has been measured multiple times before. The fact that after 10 seconds, if you load a mobile page, almost all users drop off. Now, if you've been listening to the previous stat, yes, that means 77% of all pages are likely never seen on mobile. So that's why we created AMP, to actually combat this problem, to bring back the beauty of the mobile web. And so we have 3 components in AMP: the AMP HTML, which is a superset and a subset of HTML that adds new components but also restricts some of the things that you can do. And then we have AMP.js that powers those things. And then we have the AMP caches. Now, just 2 quick examples what AMP does, a few of the things it does. For instance, it can prioritize content loading. So it knows exactly where everything is rendered on the page before all the external assets are loaded, so that we can pre-render the above the fold and not render anything else below the fold. And the caches can then use that. The platform that uses the caches to deliver your AMP pages can use that to smartly pre-render quite a set of pages. So if you're arriving, for instance, on Google search, and you get the top stories carousel, which is powered by AMP, some of those links are often pre-rendered before you click on them, which is why they feel so instant. And now if we go back one step and look at this comparison that I did before, of 1999 versus 2017, how does this look like in AMP? Well, let's have a look. Yeah, I think that looks way better. In fact, that's what you do. You create HTML markup. Because we have high-level components like accordions and all sorts of things in the HTML markup, you never write JavaScript. So you create HTML markup, you add some CSS. Out of it, you get a fairly nice, responsive, interactive content page, if you want to. And then you just hit publish, and it can be on a really cheap server, because the caching infrastructure on top automatically crawls and caches all of your content to be displayed in the apps. So you get back to a really, really cheap deployment model. So why progressive web apps? Well, they're engaging. They give you push notifications and home screen stickiness. And they're also reliable. They give you offline access and a responsive UI. And those are the things that you know usually from the native world of things. And that's a common reason why developers build native apps. But in fact, 80% of the time is spent in the top 3 native apps on a phone. And there's 0 number of apps that get installed on average per month. So that means that it's very, very expensive, for instance, through advertising, to acquire new users through the App Store model. And so what we want, essentially, is a combination of those things. We want the capabilities of the native app ecosystem, but we also want the reach of the mobile web. And we get that with progressive web apps, because they have many of those features built in, and they're also basically a website. So it's a pretty good way to get both of those things. So why is the combination of those two a good idea? They seemingly seem to attack different spaces on a different level. Well, if you just build a progressive web app, then you have the challenge that your first load is still going to be slow. And the reason is that progressive web apps are really dependent on a technology called Service Worker, a client-side proxy that accelerates and caches the delivery of your app shell, of articles, etc. But the Service Worker only kicks in after the second request. So on the first load, you don't get those performance benefits. And usually it's the first impression that counts if you want to get a new user. But then on the AMP side of things, you get no user-authored JavaScript. So we don't allow you to write user-authored JavaScript except in an iframes. There's no custom service worker, no push notifications, no web app manifest when served from the AMP cache. On your origin, that still works. But when served on the AMP cache, you don't get all of those benefits. And so that is in order to be predictably fast. So the difference really, on the AMP side, you get reliable instant delivery and optimized discovery, but no JavaScript, static content mostly. But then on the progressive web app side, the first delivery is usually slower. It's not as easily embedded as AMP documents. I'll talk about this later. But you get access to the latest web APIs. You can do whatever you want. And it supports much more dynamic content even. And to combine those two is what we call start fast, stay fast. And now, of course, you can forget all of that and simply focus on the fact that the combo makes for some mesmerizing letter animations. And if you've been doing web development in the 90s and early 2000s, I think this one might work even better for you. Wait for it. Yeah, OK. OK, let's not go there. But how do you actually do it? How do you actually get there? Well, we have 3 application patterns that make it happen. First, I call AMP as progressive web app. The second, AMP to PWA. And the third, AMP in PWA. Now, if you've been listening and I've been comparing the two, you're like, wait, AMP as PWA? We have actually, for sites that have static content mostly and don't have a lot of interactivity, you can have an AMP that is both a progressive web app. In fact, MyNet, who is one of the leading publishers in Turkey, has done that with their pages. So what you see here is a fully compatible AMP page. All of this is AMP with a full navigation concept, back and forth, carousel, whatever. All of it is AMP. And it also has progressive web app features. So it can be installed to the home screen, has a web app manifest, and so on. And in fact, just by doing that, they saw tremendous uptick in quite a few numbers. They got over 25% higher revenue per article page view. That is really the important number, because that means the bottom line is better. And 4 times faster average page load speed, over 40% longer average time on site, over 30% more page views per session, and much lower bounce rates. So in the end, really something worthwhile to do. But you can actually go further than that with that pattern. You could actually, because you have the service worker in place on your origin, you can insert anything into the AMP page that you want, random stuff that AMP doesn't like, because you are in control as soon as the service worker is running. Now, I had some nostalgia, so I thought, why not insert some 90s HTML magic into the AMP website? And I found this amazing mouse cursor, and this is exactly what I did. So here we go. I'm going to enable the service worker. I'm going to reload. And yes, I have a fancy mouse cursor and an animated background. All the things that AMP doesn't like. And first of all, what have I done? Oh! So you shouldn't do exactly that, maybe. But this pattern still comes in useful if you want to insert ads that are, for instance, not supported in the ecosystem yet, or other things that you need on your origin to run. So next is AMP to progressive web app. Now, all of this is based on a technology, on a component that we call AMP install service worker. And the AMP install service worker, the way, if you've used service worker before, you register it in JavaScript on your page. And because you don't have access to JavaScript, we have an equivalent that is AMP install service worker. But the cool thing is that this component also works when your page is loaded on the AMP cache, let's say in the top stories carousel on Google. It can install the service worker from your site's origin, from your own domain, so that subsequent clicks are accelerated. And the way this looks is, the pattern is always the same. The user discovers content. The service worker installs in the background while the user is consuming the content, and then the user is upgraded instantly to a PWA. Let's have a look at how this looks in real-world production examples. So first, let's look at Crossing, or Xing, which is a job search site similar to LinkedIn in all over Europe. And so if the user discovers content, they check out a job that they like, they click on it, and then the service worker installs in the background. And now, if they're actually interested in one of those jobs, they're instantly forwarded to the progressive web app that can add push notifications, can remind them to come back if their job is not available anymore, etc. So the next click is going to be instant. Now, next example. With Goibibo, which is a leading travel search company in India, you get the same pattern in a completely different vertical. User discovers content. Second page, the service worker installs in the background. Now, this page is a page that just shows you the hotel. But now there's a Get Availability button at the bottom. If you click that button, again, you're instantly redirected to the progressive web app that allows you to check the availability. And we could have even checked in advance in the service worker if there's availability, so that even the API call wouldn't be necessary anymore. And then Rakuten, Japanese recipe website that they've created recently, is called Rakuten Recipe. And in this case, same pattern. The user discovers the content, arrives on a recipe site. And so you browse through the recipe, you realize, OK, there's a couple of connected recipes that I like even more, or I want to bookmark this. And then the user is instantly upgraded to a progressive web app. Now, with Rakuten in particular, I have some stats to share. And in fact, if you look at the different combination of things they've done, it's quite impressive in my opinion. So with AMP, they've seen over 50% more time spent per user, over 3.6 times higher CTR within the AMP page, compared to other Rakuten recipe, actually, no, 2 other Rakuten recipe sites. And then with Add to Home Screen with a progressive web app feature, they're seeing over 70% more visits per unique user and over 3 times more page views per unique user once they install to the home screen. And push notifications, same thing. A lot more re-engagement, 3 times more weekly sessions per user after the first week, 4 times after the second week, and 5 times after the first month. And now this is really important. With push notifications, they get 3/4, so 75% lower bounces for those users coming in via push notifications than via social shares. So they're seeing much more re-engagement through that channel. OK, so this sounds hopefully pretty good, but there's still a problem. Now, if you copy the URL in the progressive web app, you share or send it to a friend, then that friend will not go through the AMP to AMP install service worker flow. So they will open the progressive web app without a warm cache. Now, what do we do with this? Well, usually you would have AMP pages deployed on one subdomain, and you have the progressive web app deployed on another subdomain, and a link from an AMP page leads to the progressive web app. Sounds pretty straightforward. However, you can change that and reuse the same domain, the same URL space for both of these. And you can do that because the service worker can intercept navigation requests. So if you click a link, the service worker can say, OK, no, I'm not going to give you the next AMP page. I'm just going to give you the progressive web app instead, even though you're on the same domain. And it's actually just a few lines of code to do that. So you check for a navigation request, respond with a progressive web app. Now, what happens if we do this? A couple of magical things, because without the service worker, we still just get AMP. So for browsers that don't support it, you always get a fast experience. And then with service worker, you get the combination of AMP in the background and the progressive web app, because the service worker intercepts and delivers the progressive web app instead. And if you don't have a service worker and you still want people to lead to that richer experience, a progressive web app that might not work fully because there's no service worker in some browsers, you can still do that with a technology that we call shell URL rewriting. That's part of AMP install service worker. Basically, what this does is it says, detect if service worker is available in this browser. If it's not, rewrite the URLs on this site to go to a fallback domain. Now, OK, we have this complete, but now we have another problem. We still have this problem with our deploy targets. We still have plenty of deploy targets. And in fact, in this case, we probably have 2 content backends. We have AMP HTML on one side, and then probably JSON or some other content backend for the progressive web app that powers the progressive web app. Now, that is where the final pattern comes in handy, AMP in progressive web app. And in fact, AMP pages aren't just web pages. They're ultra-portable, embeddable content units that can stand on their own. And if you think about it this way, if you don't think about it just as a website, some magic things can happen, because we can get from this step to this step where AMP HTML powers all of my experiences. In this case, the AMP experience and the progressive web app experience. Now, one way to do this is to build an application shell and then use an iframe. But iframes are slow. And what we do instead, because we trust the content, it's our own content, we use Shadow DOM. So how does this look like? Without Shadow DOM, you get one window. For every iframe that I initialize, infinite number of AMP library instance, and then an infinite number of documents. So lots of overhead to initialize the AMP library over and over and over again for every iframe. But then with Shadow DOM, you just have one window, one library instance that we call Shadow AMP in the top of the page, and it simply connects to lots of documents and renders them out. So that's a much cleaner flow. And in practice, the PWA hijacks navigation clicks, fetches the requested AMP page, puts the content into that shadow root, and then calls attach shadow dot. But this was a slide that showed it just very briefly. I actually want to show it a little bit more in detail because we have a little bit more time today. And in fact, I think you can do this in an hour. This flow of inserting content via the Shadow DOM, if you already have AMP pages, I think you can do in an hour. Now, if you don't believe me, let's do it in 5 minutes. OK? All right. So the first thing that we want to do is, and this is a caveat, we want to have a content source somewhere that serves as the navigation. So in this case, we need to have an overview page from somewhere that has a bunch of links, a bunch of images maybe. In this case, I just used YQL to fetch an RSS feed from somewhere, which is a really nice hack to create a compelling demo, I would say. And this gives me a nice list of articles that I can use. And I used The Guardian as a backend. Thanks again for The Guardian for letting me use their RSS feeds. And so as you can see, this is what I have so far. So this is just using the RSS feeds through YQL. And so far, so good. And this, again, this step is not so hard to do. So I shouldn't be saying this, but I started on Monday. And so next one, we add the AMP shadow library to the head of the page in our progressive web app. Now, again, this is a special version of AMP. And then we wait until AMP is loaded, which is using this technique that you find in a lot of frameworks nowadays. So this is just a wrapper that the code inside this wrapper runs as soon as AMP is actually fully loaded. And then when you have that, you fetch the AMP doc via XML HTTP request. And now, again, straightforward. You know the link from the previous navigation. You know the link to the full article. You fetch it via XML HTTP request. And then you return something that we call response XML. Now, response XML contains a ready-to-use document object, a not that well-known feature of XML HTTP request. And I'm not using fetch here because fetch doesn't support this yet. This is why I'm using old-school XML HTTP request. So now we have our actual document, our AMP document. It's not rendered anywhere yet. But now at step 5, we render it using Shadow AMP. So what we do is we create a shadow root. What this means, it's just a fancy way of saying we create a div, a container, and we give that div to and call it shadow root. Now, the AMP doc does all the magic. The attach shadow doc function does all the magic. So we give it the container that we just created. Actually, this should say shadow root, so that's just a bug on the slide. Then we give it a doc that we just fetched via Ajax, and we give it the original URL. And then in this case, we can also have a function that notifies us, a promise, when the page is ready and rendered out. Now, that's a basic flow. But there's a few things that make it even better. For instance, if you don't need certain things in the AMP page, because the AMP page usually has its own sidebar, its own navigation, so it can stand alone. But if you don't need that stuff while in embedded mode, you can actually remove those things before you give it to the AMP shadow library. You just remove the header, remove the sidebar, etc. So this is actual code from the demo. But also cool, if you don't want to do something as complex, that's cool too, because there's a class that we add to the body of the shadow AMP of the embedded page, which means that you can, in your CSS of your AMP page, you can use the .amp shadow page to simply hide things that you don't want in embedded mode. So that works as well. And finally, if you don't want to remove things, but you want to insert things back into the AMP page, features, for instance, like JavaScript highlighting or something like that, into the embed, you can do that as well by using shadow slots. And they provide a path for progressive enhancement of AMP docs when shown in the publisher's own context. So how does this look like in action? Let's have a look. Here we go. So the content experience is now all powered by AMP. As soon as you click on one of those links in the overview, the AMP page renders and loads. And because it's everything in our control, we have the whole document available, we can do some really nifty transitions to animate between those two instead of a full page load. Thank you. Now, finally, let's wrap things up. With a progressive web app, with a progressive web AMP, sometimes I also call it PWAMP because I like the sound of it, it's always fast, no matter what. There's great distribution built in. It's progressively enhanced. It's really just one backend to rule them all, and there's less client complexity, fewer deploy targets. And to visualize this last point again, remember how we had plenty of deploy targets before in our previous slide. Well, in fact, we're now down to just 3 if we want to. We have that PWA shell, the native shell, and native shell and iOS. And those are just thin layers that serve as the application shell that provide a navigation model and maybe some features on top. But then AMP is the backend that runs it all, the content source. All of those could use AMP as a content source. And so you support the web, you support Android and iOS at the same time with very thin layers of extra code. So finally, a word of caveat. When do you actually do this? Well, you do this when you have a site that has lots of static content, for instance. So you don't want to do it if you build the next Gmail, because it's really more like a really dynamic app that doesn't have landing pages, what we call leaf pages that are accessed via organic search or social discovery. So your site has to have lots of static content for it to make sense. And ideally, you already have a large corpus of AMP pages that already gets you through the first step. And this works extremely handy if your engineering resources are constrained, or to reduce infrastructure complexity. And finally, you need to test out, if you haven't done AMP before, you need to test out if your content monetizes and works fine within the AMP ecosystem. So before I leave you, and I think I have some time to open the room for questions, I'm going to leave this up for a second so you can take some screenshots. So we have a React sample app as well. That's not the one that you saw today, but it uses React, so it's great for millennials. Use the React sample apps to see how you do it in React. It has similar nice transitions. We just launched the AMP channel. If you're not sick of my face yet, you can see it again over there. And ampproject.org, we just published a big new guide about all of these patterns that I just talked about. If you want to recap all of those things and go through the tutorials, you can do that now on ampproject.org. With that, I'm going to open for questions. Thank you, everyone.